Okay, so we start with some thermal properties because last time we already discussed kinetic properties, and that is
Yes.
simple one, and mostly
Now
of you know about the basic concepts. And today we are going to discuss about some thermal properties. In that thermal properties,
Assalamu alaikum, sir.
Walaikum Assalam. How was your exam, Umair?
Sir, it was much more easier than I imagined. I was
Yes.
stressing for no reason. You know the questions that I was asking you yesterday? None of them came. Almost, I think none of them came. We didn't have MCQs in our paper today. I don't know why.
Yes. Because syllabus, when actually due to change of syllabus, there are many things that was actually removed. But still, when we are doing past papers, so when we are solving the questions in flow, so we don't think that either it is included or not. So
Yeah,
that also confuses sometimes.
Yeah, I
almost
think it's
no
just to
questions in
prepare.
chapter.
I think like to prepare you for such questions in case they come.
Yes.
I think.
We will practice according to that, but I try to remind you every time that this topic is not included because that will confuse you when you are
Wait, so
studying
which topic?
by yourself in any chapter, like in different
Oh,
chapters
okay.
we are talking about. Okay.
Okay.
So after completing this section, we will also check out the points that we completed from the syllabus, right? So that will also give you confidence that we already done with these things or not, right? Okay, so starting from the thermal properties. So in thermal properties, by name thermal, we have to discuss about some heat or thermal energy. So basically, we consider different type, or we can say that different categories of heat in this chapter. The first one, the basic one, there are two categories we can say that. First term is like known as the sensible heat. Basically, these are two terms because when we are talking about a specific heat, latent heat, and normal term of heat, so sometimes you got confused that there are different types of heat. So what type of heat we were talking about? So that's why we start with some terms of heat, and then we start with different process. So if we talk about the sensible heat, so by name, you can identify that this type of heat can only be sensed, right? Like we use thermometer to measure the temperature. So basically to sense that heat, we use thermometer. Or if you want to write definition about sensible heat, so we can say that heat that brings a change in temperature of body. So basically, sensible heat is the normal type of heat we were talking about in our daily life, right? We just provide thermal energy and the temperature of the body increases, right? So that simple concept is known as the concept of sensible heat. And secondly, if you want to explain, so you can say that it is given before or after the state change process, right? So in very simple words, we can say that sensible heat is just the basic concept of heat that we provide or that we supply to any object to change the state, just like from solid to liquid or liquid to gas. And basically, if you want to change the state, so definitely you need to supply thermal energy to the body. So that's why we write it is given before or after the state change process, right? So basically, this is the basic concept of heat. And further, if we talk about some new concepts of heat, so the second term is known as latent heat. And the concept of latent heat is different from the sensible heat. In latent heat, you can say that basically it is a very short amount of heat, we can say that, or very small amount of heat that usually take place during the process, right? Because sensible heat is before and after, right? And between that
You're
before
right.
and after, during the process, latent heat take place, right? So that a very short amount of heat or very small amount of heat during the process is known as latent heat, right? And basically it is not like the visible one, because if you consider any burner, so basically when you turn on the burner, so you know that you are supplying, or you have idea in your mind that how much heat you are providing, right? If you take the example of
Yes.
normal lighter and the example of a burner, and then the burner connected with the cylinder, so you know that how much heat in your mind, you have idea that how much heat we are providing. But latent heat is the hidden one, because it is it takes place during the process. Okay, so you are not providing that heat before and after process, it actually take place during the process. So we can say that heat that does not bring a change in temperature. So as you can see, it is a very small amount, so that's why there will be no change in the temperature. And further, it is absorbed or released during the state change process, right? So basically, this is a very clear difference between these two concepts of heat, because in our chapter, we have to consider all concepts of heat. So it's up to you that how you got the concept from the question. So don't get confused between the basic concept of heat with the concept of latent heat, right? And there is an other concept related to the heat, which is known as heat capacity. And by name, you can
Oh, okay.
identify that we are going to talk about some amount of heat stored by a body, right? Because by name, it is known as heat capacity. So capacity of heat. So basically, if we consider example in our daily life, let's suppose if you take the example of boiled water and a spoon. There is a glass of boiled water, and when you place a spoon in it, right? So, what do you think, that water takes more time to increase its temperature, or a spoon will take more time to increase its temperature? Basically, the question is, if you consider the boiling process of water and the process of increasing the temperature of a spoon, when you place your spoon in the hot boiled water, so which material or which state of matter will take more time, the boil water or that spoon, to increase its
Wait,
temperature?
what's the question?
Basically, in question, there are two different states, water and spoon, right? If you just boil
Okay.
water and place your spoon into the water, so definitely your spoon will take heat from the water and increase its temperature, right?
Yeah.
And you are supplying thermal energy to boil the water. Okay, so
Yeah.
there are two different states, liquid, solid. So what do you think? Which material absorb amount of heat, or which material will increase its temperature more quickly? Liquid or that spoon?
Spoon,
Spoon?
right?
Okay.
If it's metal, then spoon. It depends on the
Yes,
substance.
metal. Metal spoon we are using.
Yeah, then it's a spoon.
Yeah,
Yes.
because it's quick.
Okay. Spoon. So basically, all of you know that a spoon will get high temperature as compared to the water in short time interval, right? So basically, we have to supply some heat energy to the body. So then the temperature of the body will increase, right? So that is the concept of heat capacity, that how much amount of heat we provide to that specific body that increases the temperature of body to 1 degree Celsius, right? Let's suppose if your water is at 20 degree, your spoon, metal spoon is also at 20 degree, right? So now we have to find out that how much amount of heat water and spoon required to raise their temperature by 1 degree, right? I will write the definition. Amount of heat required, or we can say that amount of heat that can be stored in a substance for unit change in temperature, right?
Right.
Okay, so basically, if you compare different states of matter, right, like solid or liquid, basically we can compare solid and liquid in our daily life very easily. And you all know that a spoon will increase its temperature very quickly as compared to the water. So you know that a spoon require less amount of heat, right? And water requires more amount of heat, because when we starts to boil water, so water will take more time to increase its temperature and to boil till 100 degrees Celsius, right? And as compared to the water, as compared with the spoon or the metal spoon, so metal will quickly increase its temperature with short amount of transfer of heat, right?
Yeah.
Clear? Any confusion?
No, sir.
And can you explain why the amount of heat will be less for solid, or why solid will increase its temperature very quickly as compared to liquid? Can you explain that?
Right, can you repeat?
Question is, if we are talking about liquid and solid, right? So you know that in solids, like in metals, we are comparing with metals in solids. So if we take metal, if we take water, so why the amount of heat, or why the temperature of that metal increases quickly as compared to the temperature of that liquid? You know that we are providing less amount of heat to solid, that is metal spoon, and we are providing more amount of heat to water. So why water requires more heat, and why that metal spoons require
Because
less heat? Hmm?
because the amount of heat for a liquid
Hmm.
needs to be high because they have the energy to overcome the forces, no?
Okay, so basically
Like
for that process,
intermolecular.
yes, in that case we have to provide more heat to the solid. If you are talking
Yeah,
about,
it's because the molecules are fixed in their position.
yes,
So I have to put more heat in the solids.
is it because of the molecules in solid and liquid? Yes. So
Yeah.
basically, the main theme is related to the molecules, right? So basically, in solid, molecules are very close to each other. So it is very easy for solid to transfer energy, right? As compared to the liquid, in which molecules are not tightly packed, and they will take more time to transfer the energy, right? So that is the reason that in solid we can easily transfer amount of heat as compared to liquid and gases, right?
Yes.
So we can say that heat capacity, so we have to provide less amount of heat in solid, and we have to provide greater amount of heat in liquid, right, as compared to the solid. And let's suppose if we consider the symbols, so basically for temperature, you know that we use that T. So T represents the temperature, and the heat capacity can be represented by the symbol of C, right? So C is the symbol for heat capacity. Okay.
Yeah.
And if we
Right,
talk
so
about,
can you re-explain why solids have less heat capacity?
because molecules are very tightly packed, and you know
But
that when
sir, won't the
tightly packed,
okay, okay, explain.
it's easy for them to transfer heat energy, right? Let's suppose if there are 10 students just making a straight line, and 10 students are standing in a one row, and you have to transfer one box to one point to another, right? So they can transfer very easily because they are 10 in quantity. And if you just reduce them to the half, so you know that gap between the students now increased, right? So now they have
Yeah.
to transfer that box from one student to the second, then second to the third. So they will take more time, right? So that is the
Yes,
process
it
for
would.
solid and liquid, right?
Yeah, I got it. I got it.
But why is
I thought if
liquid
the molecules
greater?
are closer, you would have more heat capacity.
Oh,
If for
okay.
solid, you have less heat capacity, right? You have to
Yeah, yeah.
And
amount of
for
heat.
liquid?
For liquid, you need to supply more amount of heat.
And for what do you call gas, you have to supply the most.
Yes,
Yeah, that's true since the particles are like going everywhere
yes.
for the gas.
Yeah.
Okay, and there is a very simple question. In question, it is mentioned that the initial temperature of a liquid was 25 degrees Celsius. So this is our initial temperature, and then this temperature increases to 30 degrees Celsius, right?
Yeah.
And the amount of heat you provided is equals to 10,000 joules. And one more thing, for heat, we are going to use the symbol of Q
Q.
or
Okay.
delta, right? Because when we are providing thermal energy, so definitely from initial to the final point, there will be a change in heat, right?
But so do we use Q for both sensible and latent heat?
Yes, yes. For any type of heat,
Okay.
you use the same symbol Q, right?
Okay.
Because if they ask about latent heat, so they will ask by name that find out latent heat, what will be the latent heat, or like this. And if we are talking about just normal heat, so they just use the word of heat energy, just like in this question, right? So this is the amount
Yeah.
of heat given in your question. And calculate the specific, or sorry, calculate the heat capacity of liquid, right? So you know that values are given. T1 is given, T2 is given, and further Q is given, and you have to find C. C is unknown, right? So now we discuss about specific heat. Sorry, we discuss about heat capacity, but we not know that how to calculate the heat capacity. What will be the formula, right? So according to the definition, you can see that amount of heat that can be stored in a substance for a unit change in temperature, right? So from definition, you can easily identify that C must equals to amount of heat change in temperature, right?
Yeah.
So this is the formula for heat capacity. So now you can use this formula to find out the value of C. Okay.
What is Q again?
Q is heat energy.
Oh, okay. Oh, okay.
2000.
So you will get answer 2000.
Yes, I got it too.
Do we say joules or like?
Yes. Now the important thing.
Yeah, since
We studied about many concepts and many quantities, many SI units. So let's try to figure out what will be the SI unit for
Joules per degree Celsius, no?
joules per
joules.
We're
and
dividing by temperature, right? So per degree Celsius.
yes. So basically, we are working in degrees right now. So your SI unit will be equals to joules per degree Celsius, right? So this will be your SI unit. So this is the very basic concept related to some types of heat, right? Further, if we continue with some other concepts, so there are some more quantities. Okay, if we further compare latent heat and the sensible heat, that is the normal condition of the heat. So there are some more points and there are some more differences that will help you to identify the clear difference between the sensible heat and the latent heat, right?
Yeah.
So if you consider latent heat, so we discussed that latent heat is the amount of heat that takes place during the process. So basically it absorbed or released during the state change process, right?
Like before or after?
No, it latent heat is in the middle.
Oh, so like it's
Before
in
and
the
after.
middle. Okay.
Yes, during the process. So it take place during the process. So for latent heat, we can say that
Like, doesn't the sensible heat, like in the middle of the process, it converts to latent
basically
heat?
sensible heat is supplied before or after the process, right? During the process,
Yeah.
the change when change take place over there. So during that change,
Yeah.
so that amount of heat during change is known as latent heat, right?
Yeah, so it converts from sensible heat, then moves on to
Yes,
latent, doesn't it?
yes. So basically, we provide sensible heat, and that converts into, you can say that in the sense that will converts into some part into latent heat, right? And we use latent heat to
Yeah,
overcome
that's what I was
thermometric
thinking.
forces. Yes, and separate separate the molecules from one another. Right? So basically latent heat helps you to do work against the intermolecular forces, right? And during this process, one more important thing that you need to remember, because in heat capacity, we discussed there is a change of temperature. In sensible heat, we also discussed there will also a change in temperature. But in latent heat, there will be no change of temperature take place, right?
So the temperature remains the same, right?
Yes.
Okay.
And one more thing, vibration of molecules stays the same, because you know kinetic energy is directly proportional to temperature. If your molecules vibration increases, so definitely your temperature will increase, right? So it means
And
that,
the kinetic energy will increase as well, right?
yes.
Okay.
So variation vibration of molecule stay the same. So for latent heat, we discussed that vibration of molecule stays the same, so temperature also stays the same. So this is the concept for latent heat that will also help you in the concept of latent heat or difference between sensible and latent heat. Because in both sensible heat and latent, in heat capacity, you observe that temperature will change, but in latent heat, there will be no change of temperature. And further, if we talk about some concept related to heat capacity, so basically, heat capacity is not a material property, right?
What, sir?
Yeah, heat capacity is not a, like a material thing. I
Yes,
don't think
because
so.
sometimes we are thinking about that might be heat capacity depends upon the property of a material, right? Basically, it does not depend upon the property of material, right? Because if we take the example of solid, right? So in solid, you can also take the example of the ice cube, right? So ice cube is also a solid that can be formed with the help of liquid, right? So that's why it does
Yes.
not depend upon the property or any type of material property, right? So that is the concept. Because there is another concept related to heat capacity that we discuss after this one, that is known as specific heat capacity. And in that concept, we include the quantity of mass, right? So that will further specify you that heat capacity actually depends upon the mass, right?
Right.
So it is not a material property, because in your formula there is no such element that specify you that we are talking about any specific material.
The heat capacity, like it does not rely on a material for it.
Basically, it depends upon,
Sir, isn't that the specific heat capacity which depends on the mass?
yes. So basically, we are going to discuss one more advanced level of,
Wait, sir. Sorry. Can you re-explain why it doesn't depend on material property?
Yeah.
basically, if you consider different states of matter, right? You are taking the example of a spoon and you are taking the example of liquid, right? As we compare already. So basically, if you just freeze that liquid, right, and that will turns into a solid ice cube, right?
Yeah.
Basically, we discussed that in solid, transfer of heat will take place very quickly as compared to the liquid form, right?
Yeah.
Basically, it depends upon the molecules formation, right?
So it depends on the state.
uh, you can say that it further depends upon the state, that what type of state we are taking over there. But if you compare like in metals, there is some different amount of heat. In liquid there are some different amount of heat, because if you take the example of what type of metal which is in liquid form, did you remember that?
Gallium,
Mercury, right?
mercury. Yeah.
Yes, so
But isn't
mercury.
gallium also one of them?
Yes, that is also, but the most common that we use is the mercury, right? So mercury is
Okay.
also a metal, but that can also be exist
It's like
in
liquid
liquid form.
though.
Yes, so it is in exist in a liquid form, but it's still,
At room temperature.
yes, it is a metal, right? So basically, the main thing is never compare heat capacity with different type of material, right? So basically, it depends upon
Oh,
the
okay.
amount of mass, the quantity of matter in a body. Okay.
Huh.
Yes, because you are saying how?
No, I'm saying I was like agreeing.
Yes.
Yeah, me too.
You are still confused why it does not depend
No,
upon.
no, no, I'm not.
Okay. Because
Yeah.
first we only discuss about heat capacity. So that is related to the concept of heat capacity, that what is actually heat capacity. And there is another concept, specific heat capacity. And when we are working with the specific heat capacity, so in that definition, we are going to use the concept of the mass, right?
Wait, so there's a difference between specific and
Yes,
just heat
basically in
capacity?
heat capacity, there is no concept of mass. Just like in question, you can see there is no concept of mass included over there. We are just talking
Okay,
about general thing with respect to the amount of heat and the increase and decrease of the temperature, right? Because in
okay.
definition, it shows you amount of heat we provided in a substance, right? Because if it depends upon the property of material, so definitely in definition, we have to write like for solid, for liquid, or for gas, but there is no such concept. So that's why we only wrote over there it can be stored in a substance. So basically it depends upon the mass like this. Greater mass, it means that the large amount of heat, or we can say that the larger the heat capacity is. Okay. And further, if we talk about the concept of specific heat capacity,
So the more mass there is, the larger the heat capacity will be there, right?
yes.
Is the same true for like if there is less mass?
Yes. So definitely, let's suppose if you take a very small
Oh, okay.
quantity of liquid in container, right? So that will consume heat
Mhm.
and raise temperature very quickly. And if you just take a very large container of water, so definitely it will take time. So that's how it depends upon the mass, right? If it depends upon the material, so a glass of water and jug of water both will take the same time to heat up, right?
Yes.
But you know that it depends upon the quantity, right?
Not, yeah, the quantity of it.
So that is the only thing that we are talking about. So specific heat capacity, So in a specific heat capacity, there is a concept of a unit mass also. So we can say that amount of heat required or amount of heat needed to bring a unit change in temperature, right? We just need to modify the previous definition. Amount of heat needed to bring a unit change in temperature in a unit mass of substance, right? So basically, if you want to find out a proper specific value for any material, right? So you need to take a unit mass of any object or any material or any state, right? Just like if you are going to find out that how much heat is required for 1 gram or 1 kg of water, right? So for that, you need to take a unit mass, right? So that will help you to exactly find out the exact value of the amount of heat you are providing to a specific
Oh,
material or a specific amount
okay.
of substance. Okay.
Okay, sir.
So this is the concept. And further, if you want to write the formula, so formula also includes the quantity of mass. Otherwise, all quantities remains the same. So your formula will be equals to C is equals to amount of heat required to increase the temperature by 1 degree of unit mass. So this will be your formula for specific heat capacity. And for SI unit, you can easily identify that your SI unit for specific heat capacity will be equals to joules per kg per degree Celsius. So this will be your SI unit.
Sir, I have a question.
Yes.
According to the formula, aren't mass and the heat capacity inversely proportional? Like mass increases, then the heat capacity will decrease.
Yes. So basically, the greater, that's why we are writing greater mass require larger heat capacity, right? Because
Yeah, right.
yes, because if you want to boil 1000 ml water compare with 100 ml water, so definitely for 1000 ml water you need a high amount of heat, right? Otherwise you have to wait for long, that 1000 ml will boil at 100 degrees Celsius, right? So basically when you consume more time, so definitely it will consume more amount of heat, and 100 ml of water will boil very quickly
Okay.
compared to 1000. So that's how you know that both are inversely, that was right. But if you are comparing with the specific mass with the specific heat, so that is something different. But if you compare with the practical example, so you can easily compare different quantity of liquid or any object. Let's suppose if you take 1 centimeter a cube of solid and 5 centimeter cube of solid, so definitely 1 centimeter cube will quickly heat up and increase its temperature. So it required very less amount of heat to increase its temperature as compared to 5 centimeter cube of metal, right?
Okay.
So these are the basics thing, right? So that's why I am writing all this thing in detail, because sometimes in exam it confuses, right? Because all are related to heat, and by concept we got the wrong concept in the sense that it depends upon the material, right? But is not depending upon the material. If you take the spoon, or if you just take a steel rod of 20 meters and you compare with the water of glass, so definitely water of glass will quickly heat up, because 20-meter steel rod has a very long length and very large number of molecules, so it will take more time to increase its temperature. So that's why it depends upon the mass, not on the material property. Okay, clear? Any confusion?
No, sir.
There is one more question. A container having some water was used to find its heat capacity. An electric heater of power rating 500 watt was used to heat water for 5 minutes. Because last chapter we discussed is related to the power. Okay. So now you know that we can easily compare the concept of power and temperature and heat. So the temperature arises from 25 to 40 degrees Celsius. So there is a change of 15 degrees Celsius in temperature. Okay. So let's try to solve this one. So change in temperature is 15 degrees Celsius, right?
Yes.
And a container having some water used to find its heat capacity, right? And all the things are also given. Okay. So basically, first we find out the heat capacity. So heat capacity can be find out with a simple formula. C is equals to Q over T. Okay. And what is the amount of heat that we actually supply? That is the problem. That how to calculate it.
Suppose, what if you don't know?
Yes, because the amount of heat is not given, but they give you some other concept, because you know that heat is also a type of energy, and we already studied the chapter of work, energy, and power. So now you need to know that how to find out the energy from the given data, right? Can someone identify that how to find out the amount
Uh-huh.
of heat, or you can consider amount of heat as energy, so that will simplify your concept. Basically, you need to find out the
Is
energy.
it is it 500 watts multiplied by the time in seconds?
Yes. So basically, you know that a rate of change of work done, or rate of doing work, or rate of change of energy with respect to time is known as power. So we have to use the formula of power. Or we can write Q over T, right? So basically, Q will be equals to P into T. P is 500 and T will be 5 into 60. That will give you answer in seconds, right? So basically that will give you the value of amount of heat. So this will be the amount of energy we are providing to the system. And if we substitute this value in our main question, so that will be equals to 10,000.
Yes.
So this will be your answer for heat capacity, right? Now you can see how we can relate, because in past papers and in topical worksheet, you also find the question uh, that is related to energy with heat concept. So these type of things are included. That's why we are not solving that question at that moment, because we have to study about heat capacity formula, right? And further,
Wait, sir, can you re-explain? I wasn't here. Sorry. I understand the time part,
yes,
but what are you using the power for?
basically in question you can see there is no concept of amount of heat given, right? So when
Yeah.
amount of heat is not given in the question, so definitely we have to find out the amount of heat by our own, because other quantities are given over there, right? So basically
Okay.
you can see that power and time is given.
Yeah.
We already studied the concept of work energy power. And in work energy power concept, we know that rate of doing work is known as power, or we can also write power is equals to energy over time. And thermal
Yeah.
is also a type of energy. So we can write over T, right? So then we just shift the value
Ah, okay.
T
And then you just substitute the values. Okay,
time in
understood.
seconds. So that is the simple thing we do over here. Because in
Sir,
Yeah.
Hmm?
the you wrote 10,000 joules. Isn't it joules per degree Celsius?
Yes, sorry. That is a specific heat, joules per degree Celsius.
So can we say 10 kilojoules per degree Celsius? Would that be allowed?
Basically,
I'm not
we are
sure.
just only working with basic formula. So when we are doing a proper past paper question, then we will also follow significant figures, because for the time being, it is important to learn about the concept. So that's why I just take a very simple basic short questions to observe the difference, right? So don't worry,
Ah, okay.
try the topical worksheet. So in that, you know that we are doing with proper procedure that should be followed in your exam.
Okay.
And one more thing that we were talking about, that why heat capacity depends upon the mass. So there is another example in front of you. If you take 1 kg of gold and you compare with 1 kg of water, right? So different materials store different amount of heat energy. Water takes about 30 times longer to heat than gold, meaning it stores about 30 times more calories, because a gold can be heat up very quickly as compared to the water, right? So basically heat capacity, the word capacity actually means the amount or the total capacity for a substance that can store heat, right? Because we discuss about good conductor, bad conductor, and you know that there is a material filament we use in the old bulb. So the melting point of that metal is very high, right? So that's why scientists use that metal piece for the light purpose, because he knows that the melting point of filament is very high. So you can see that spring type wire is still got very high amount of heat, but still it will not melt or break. Okay, so that's why it depends upon the mass. And if you talk about different storage of heat energy, so it also depends upon different materials, right?
Sir, what is the SI unit of calories?
Cal
Does it even have a unit? Yeah. Does it
basic
have a unit?
no, calories is itself a unit, but we are not using in our syllabus. That is not included, and that is not SI unit. So that's why we are not using that in our syllabus or in our thermal section. And if we talk about the water, there is a proper procedure how to find out the specific heat in laboratory, right? I will share a video with you for the live practical demonstration that how in laboratories the setup actually set. Basically, we take a metal pieces like a size of bullet type metals over there, different pieces was there. And first we just heat up that metal shots, and then we place into the water. There is a thermometer connected with the water, and temperature actually rises, and we just take a stopwatch to note the time period, that how much time it requires, right? Because in formula you can see that the formula of a specific heat contains C Q M delta T, right? So mass can be measured with the help of a spring balance, temperature can be measured with the help of thermometer, and specific heat can be find out with the help of the formula. And for heat, you can see we can find out with the help of power, time, and all other things. So I will also share that video with you. You can observe that video how to find out the specific heat practically in your labs, right? So any confusion in these concepts?
No, sir.
Because these are basic concept and there is no such problem for you, because formula is very short, very simple, and there is only one formula, and second one is the modified one, because you just need to add mass in denominator. Otherwise all the things are same that we are using over there. Okay.
It's just masses there.
Yes, because when you are working with specific, so specific means specific mass. Otherwise general concept, overall material we are taking over there.
All right.
Okay, any confusion, any question?
No, sir. No, sir.
Okay, so in
Sir, I do
next,
have one.
yes,
It says water takes about 30 times longer to heat than gold, meaning it stores about 30 times more calories.
because it when it takes more time, so definitely you are providing thermal energy to the water, and you know that water boils at 100 degree. So at 100 degrees Celsius all thermal energy is going to be stored into the water. Then after 100 degrees Celsius it starts to convert into gaseous state, right? So that's
Yeah,
why
but sir, why does it say calories?
basically this is a very just a random picture to show you the difference between different materials, right? So just ignore that word calories, right? Or you can
All
say
right.
30 times more amount of energy, right? Because calories
Yeah,
is
yeah.
our SI unit. That is only just for the reference, right? So
Yeah.
next time we will start with some different process also, like evaporation and boiling process. What is the difference between them? There are some factors on which evaporation depends, right? So that was the important concept. And one more important topic in this chapter is related to the graphical representation, because when your state change take place, so there is also a graphical representation, that if you take a ice cube, that ice cube melts into liquid, then liquid turns into steam. So there is a proper graph from solid to
The
liquid.
heating and cooling curve.
Yes. So that behavior and that graphical representation is very much important, because that is included in your exam. And evaporation and boiling, the difference between them is the most important thing in this chapter, right? So in next class inshallah we will discuss that, and we will also solve some question in next class, right?
Okay.